So the last couple days I've been doing a lot of work around trying to figure out different ways of creating particles on a circle and using particle strips to try to make some cool effect. But I've just run into a lot of situations that a lot of dead ends, and I can't come up with anything really cool to show, but I have learned a number of things that I think could be useful. So this is kind of a conglomeration of a couple things. First of all, how to create a uniform circle. So before, for our other videos, we were creating the particles in a torus. And anytime you're creating particles using one of the initialized particles with torus or arc circle or cone or anything, they're always random, which in a lot of cases fine. It worked for our effect that we were working on, but I have seen some effects using like a uniform circle, meaning that all of the particles are coming out uniformly spaced around a circle. And so I wanted to figure out how to do that. So that's the thing I'll show first. So what I have here is I'm creating a single burst of particles, and I am calculating the position of where they're going to go. And I'm doing that in this way. So if we look at this, what's happening is I have an arc circle to define a radius, and that's what we see here. I have this arc circle selected, which is why we see the circle dimensions here. And what I'm doing is I'm using this spawn index, and the documentation doesn't really help a lot with understanding what these attributes do, and I played around with a lot of them. The spawn index specifically seems to only be set when you're doing bursts. Maybe I'm doing something wrong, but if I do a constant, it just doesn't get incremented at all. But in this case, since I am doing a burst, it can be used. So what I'm doing is I'm using the spawn index, and essentially what I'm doing is I'm creating my own circle. And if you look up the definition of a circle, is a circle can be defined by sine and cosine. And so essentially the cosine of an index that's going between 0 and 2 pi, in this case what I'm doing is I'm taking that index that's going from 0 to 360, and I'm multiplying it by a conversion factor of pi over 180. So essentially what this is doing is it's converting that 0 to 360, which is a degrees, into radians. Because generally whenever you're doing math in a computer, it's always in radians. And it's important to understand whether you're dealing in radians, which of course goes from 0 to 2 pi, versus degrees, which is going from 0 to 360. So in this case, these do deal in radians. So I'm multiplying it by pi over 180 to convert this that's going from 0 to 360 into radians. That's what this first part is doing. Then I'm taking the cosine to figure out the x component of my plot, taking the sine, which is the y component, and then I am adding it to the center point of my circle just to localize it into my scene. And then I am multiplying it by the radius, because these are going to go from 0 to 1 essentially. And so by multiplying it by the radius, we're converting it from 0 to 1 to whatever the radius size this is. And then I'm using that to set the initial position of my particles. So it's bursting, in this case, 10 particles. It's using that particle index to feed into my circle formula and then setting the x and y position. And you can see here's my x, here's my y, my z is going back, which is 0. So I start to see my particles on my circle. I see 10 particles. I have no lifetime set, so they'll just live forever. I'm not updating them, they're not moving, and I'm setting the size to 0.1 in this case. So you can see I just have 10. If I change this to 90, what we see is it's going to form 1/4 of my circle arc. If I go all the way to 360, you can see it fills my whole circle. So in this way, what I can do is I can create a burst of particles and have them form a circle. So that's the first kind of step that I want to go over to understand how to get my particles on the circle. And again, I could modify this radius here. See, and change the radius of my circle. And again, it's multiplying that position from the sine and cosine by the radius in order to make it follow the exact radius of the circle. So that's kind of step one. So step two is to apply some of our other techniques for standing up and rotating our particles if we want to use them in a column similarly to how we did before, or you can just spew out particles very small that that don't form a column. They just use some other technique for, I've seen, just to make some other effects. But first of all, I wanted to understand how to get that uniform circle set. So that's kind of step one. So now let's work on step two, and let's stand these up and give some movement to them that you could use to make an effect. So the next thing I've done is I took our standard circle. So this is what we saw before. This is the standard code that was taking our spawn index and creating our positions on our circle. But what I've done here is, instead of just feeding in the spawn index, I'm multiplying it by an exposed variable called particle number, the number of particles I want in the circle. And I'm dividing that into 360. So if it's 360, it's just going to be 1. But if it's anything smaller, so say 90, it is going to be 4. And so essentially, if I have this spawn index and I only have 90 in mine, then it will go every fourth one. So basically, it's going to space them out evenly around the circle. And then I use that same particle number to have the count of my burst. So that's the first thing. So that allows us to say, how many particles do I want in my circle? Secondly, I took, and if you've watched my other videos, I subtract my position from my particle position, do the cross product, normalize, do the branch, multiply by 90 or negative 90, and then set the angle. So that stands up, as you recall from my other videos, the particle. So it's kind of orientated vertically, and it rotates and moves, so it's always parallel with the, basically to the tangent of the circle. So that's the second thing. And then this kind of shows what you can do. Again, this isn't any cool effect here, but it kind of can show you what you can do. Since we know the position and it's uniform around the circle, I can create patterns in my colors. So you could feed in, you could actually feed in an image. You could have a column of particles that actually show an image by feeding in a pattern of colors, since it's uniform, that are going to rotate around. So in this case, what I'm doing is I'm just doing a little bit of math to do every other color. So what this is doing is it's saying if it's even, do one color, red. If it's odd, do another color. And I take the index, I divide it by 2, I convert it to an integer, I multiply it back by 2, and I say if it's even. Say if it was 4, it's going to divide 4 by 2 is 2, it's going to multiply back to 4. If it was 3, it's going to divide, and when it converts that 1.5 to an integer, it's going to go to 1, you multiply it back by 2, it's only 2, they're not even. So essentially it's just checking for even and odd. So you can see the result of that. You can see they're red and yellow. The last thing I did, and since my other videos, I discovered there is a lot of different nodes that you can do. And one is this Rotate 3D. So instead of having to modify the vector by that cross product, you can actually use this Rotate 3D node. And I have this rotate speed. And again, the rotate speed needs to be very small because this is feeding in on that update. And if you recall that the change in velocity happens a lot, many times per second. And this is going to update many times per second. And so that angle needs to be very small. And I assume it's the amount of angle it changes per update. And then I connected that to this rotate speed. So you can see, nothing very spectacular here. If I select this and change the particle number, say if I change it to 4, you'll see it only does 4. They're outlined because I have it selected here, so it always selects all the particles. I think I'd have to change something up here to turn that off, but it's not a big deal. We can change the size, right, to make bigger particles, smaller particles. I can change the delay. So right now it's spewing out one set of particles every second. If I do this down to 0.1, you can see it's going to do a lot of particles. And again, it kind of loses the effect since they're not being, they're not dying out, they're not getting smaller, they're not getting bigger. It's really just to kind of show what you can do here. If I change the rotate speed, say to 0.08, right, it's going to do it a lot faster. So I can get almost a solid, right, a solid set of stripes here. Change my delay down to 0.01. So again, you can use this to create patterns of rotating columns, right? I didn't expose the upward velocity here, but if we can change this to 2, again, we get this kind of stripe effect of a column coming out. So you can see it's useful for creating patterns of things versus just random look of things if that's what you need to do. So this is one way to get those stripes. But another way is to create particle strips. So the other thing I've been playing around with is creating particle strips off the particles. I'm sure if you've seen other videos, they use particle strips for various reasons. And there's a couple things that I discovered with particle strips that I'd just like to show in this video. So I'll be showing you how to kind of explain how particle strips work. It's not really obvious. I mean, you can use them without really understanding them. So I'll explain a couple things that I've discovered on those. All right, so what I have here is I have a VFX graph. And what it's doing is it is creating a burst, the same as we did before. In this case, it's just a single burst. So before we had a periodic burst, which you can have it keep putting out a burst of particles with some delay in between the particles. So we showed how that can spew out a lot of bursts of particles, x times a second. In this case, it's a single burst because what I'm doing is what I wanted is a circle of particle strips, or a particle strip that formed a perfect circle. And the idea would be that instead of making a lot of particles together, I just want a solid line, basically, of a circle that I could manipulate and move around for a particular effect. And so when I did this, so what we see here is I have our same formula for creating our circle with our sines and cosines. In this case, instead of creating a particle quad, I am creating a particle strip. And so you can create these, just you can choose what this block is. And so instead of a particle quad, it's a particle strip. And I'm setting the position. And what I'm using is this spawn index in strip instead of the spawn index. So you have to use this property instead of that spawn index. But it works the same way. When I do that burst, I get X number of particles. And in this case, I have it set to 361. And I'm creating my circle. But you'll see that it's not forming a solid strip. And you can see that if we zoom in, it's getting thinner here. So what's going on? Well, and you can kind of see what's going on because the orientation of the strip is always in the Y direction, right? And I can make it wider. So I come in here and I can set that size to bigger, but it didn't make it any fatter. It just made it taller, right? And that's what the size does in a particle strip, is it makes it taller. And so I'm like, well, this is odd. Why is it doing that? And there's really, and again, I look across a lot of the different nodes and the node options, and I could find no way of causing it to rotate without rotating it myself. So really that's what you have to do. So in order to do that, what I did first of all is I wanted to have better control to see exactly what was being rendered. So instead of a particle, I made basically this solid square. It's basically just as it says, it's a solid square image, so I could see exactly what was going on. And so this makes it kind of clearer that you can see as it's going around the circle, this is where it aligns vertically, so this is the width, but then it gets thinner because again it's always in the vertical orientation. So what I need to do is I need to rotate that. So let's set it back to 0.2 and take a look at that code and how I made that work. So what I did is I take my spawn index, and in this case I can actually use, there's a formula for calculating the rotation. Well, actually this isn't using the formula, that's in one I'll show next. What this is doing is it's essentially multiplying it by, again, our pi over 180 in order to convert it to radians. And then the fact is that the rotation needs to be, if you take the cosine of that, it's going to, at cosine of 1, right, it's the x value, and this is when the x value is 1 essentially, it wants to rotate 0, and when the cosine of 0 is 1. And so essentially when it's 0, I want it to be rotated 90 or negative 90. And when it's at 1, I don't want it to be rotated at all. And then anywhere in between, I want to rotate it by that cosine. So I can just take the cosine of the x. And then I can multiply it by my negative 90 or 90 based on whether I'm less than or equal to 180. Again, on one side of the circle, it's going to be 90, the other side negative 90. And then I'm going to feed that into the z. Remember, the z is going, we select this, the z is going out in this direction. So I'm rotating around the z-axis. So if I uncheck this to enable that, we can see we get our nice solid circle. The other thing you'll notice is I have a white line in the center of it. And the reason I have that, and this is the other thing you can do is, again, when you output, you can output multiple types. So in this case, we're outputting that particle strip quad type particle, and I can also output a particle strip line. And I did this when I was debugging it, just when I was trying to figure out what was going on. I just drew the line to see, am I, is all my other calculations correct, right? And so I can get this line, but it also demonstrates how these blocks, you can create these blocks just by the same way you create all those other ones. You can see these are all the output types you can actually create. A lot of times it's using this, the quad, the particle quad. In this case, it's using the particle strip quad. But you can output these other ones, and the one was the particle strip line. So that kind of shows how you can use a circle. I was playing around to try to figure out some cool effects with the circle, and none of them really worked out. But it does kind of show you can utilize this again for some of your base effects. And it kind of shows how you can use the combination of that uniform particle distribution along with a strip line to get a solid circle. Okay, so for this last part, the first thing we need to do is understand how to calculate the angle between two lines. And you'll see why we need this in a minute. But I wanted to look at the formula, and understanding trig is very helpful in any graphics, because there's a reason why they give us cross product and dot product and sine and cosine modules, because they are used a lot in graphics, because you are rotating things and calculating directions and calculating vectors. So this basically is the formula for finding the angle between two lines. So given two lines, we can find the angle, and this is basically the formula. So that dot is the dot product. So it's the dot product of A and B, or two vectors, over the length. That's what these two lines mean, the length of A and B. So the cosine of the angle equals this. And so we can actually calculate the angle by taking the arc cosine. Remember, if you take the arc cosine of this side, we just left with the angle. So if we take the arc cosine of this formula, we will get the angle between two lines. So I wanted to look at that first, so we understand that. And again, the dot product is really just that the x components multiplied together plus the y components. So what we got here is, this is the formula, that formula using our nodes. So what we're going to do is it's going to take the direction. And remember, the direction is the vector. Direction, and this is confusing. If you look up what the direction node is, the direction node, from everything I can find, is not set by anybody. You can set it yourself to use to help you move particles in a direction yourself. So basically what the direction is it will always be a normalized vector for you. So the direction is the vector that the particle is moving. And again, I didn't realize this until I read the manual, but it is automatically normalized. So I really didn't need to do this normalized vector. And what I'm going to do is I'm going to find the difference between that vector, the direction, and basically a direction in going straight in the x direction, which is this. So I'm finding this angle here between this this line and this line is what this is doing, and I want to find that angle. So I'm taking my two vectors, I'm taking the dot product, and again, they give us a node to do that because it's a common thing to happen. So we take the dot product of those two vectors, we take the arc cosine of it, which is the angle. They don't really define whether these angles are in radians or in degrees, but just by a little trial and error, it is in radians. And so basically what I do is I'm converting it to degrees. I'm doing it the opposite of what we did before, and that's multiplying it by 180 over pi, which converts that radians to degrees. And then I'm multiplying it by that in order to get an angle. Because the angle is in degrees, this is in radians. And then I'm taking the absolute value of that because it can be negative, and I always want it in the positive direction. So that's basically that angle formula. And I wanted to go over that first. So now basically what I have is it's a pretty simple system. I'm spawning a particle and I'm moving it in some direction, right? I got this velocity x and y that I've exposed, and right now they default to 1, so it's just moving in a 45-degree angle up and to the right. And what I'm going to do is I'm going to set this direction. Remember, it doesn't get set by itself, and I'm going to set it to the velocity. So basically the velocity is defining the direction that the particle is moving. And so I'm setting that direction. And then what I'm doing is this is the normal way we use the particle strip to make a trail. Basically, if you're using the regular particle system, not the VFX graph, you can set the trail, which is basically what the particle strip is. So what it's doing is it is triggering an event over time 10 times a second. It is going to be creating a particle strip item. That's what this is doing. That's what this trigger event rate over time is doing. And this is the typical way you get a trail, is that you set that rate. The 10 is somewhat of an arbitrary number. In this case, it really doesn't matter. And then I'm going to initialize the particle strip. I have the capacity. It creates a particle strip of 16 elements per particle. The example before, we were creating our own particle strip and defining the number of particles. And this way it is creating this particle strip off this trigger event. And I'm going to inherit the direction. So the direction, and this is important, the direction that I set over here is going to be carried over into the particle strip because I need to know that direction. And then I'm going to inherit the position, and you need to do that to make sure the particle strip is created right where the particle was when it was uninitiated. And I'm going to inherit the lifetime to make sure that once my particle ends, my particle strip ends. So that's pretty typical every time we make a trail. Now what I'm going to do is, let's go over here and look, and you can see that, right, my particles are orientated vertically. Just like before with that circle, every time you make a particle strip, it's going to be orientated vertically, which means that, let's go over, shrink this down a little bit, move this back. If we change this velocity, if we change the velocity y to 0, you can see the particle strip looks great. Let's move this up a bit because vertical orientation is what we want, and we see our nice fat strip, and that's cool. If we change this to 0 though and make it vertical, it's like, hey, what happened to my particle strip? Basically, it's super, super thin. Because again, it's orientated vertically. So if I make this like 0.1, you can see it's going to be thin. So if we have our particles moving in some random direction, sometimes our particle strip is going to be wide and sometimes it's going to be thin. And I noticed this when I was working through some other videos, making some lightning effects and that. I'm like, why? I don't understand what's going on. It's really thin sometimes, and I didn't understand why. So I dug into this to try to figure this out. And I made this little demo. You can see all of these items here are my VFX graphs that I've used to try to understand some aspect of how the VXF graph works, because that's what you need. You need these little test graphs in a controlled environment to kind of figure these things out. So we have calculated the angle, and what I want to do is I want to rotate my strip around that angle that I calculated. The difference between this vector and this vector. So you can see in this case the angle is really big, and so I want to rotate it quite a bit. I need to rotate it by the exact same amount of this angle. And that's what this set angle is doing, is we're setting the angle of our strip to match that angle. And so then if we enable that, we can see now we get this nice fat line correctly. So now no matter what angle I make this, it is going to be rotating that line to match that. And so now I can move my particle and have it going in any direction, and as long as I can pass in the direction that the particle is moving, I can rotate my line just by using this formula on my particle strip. Calculating that direction from a velocity is easy. The direction is the velocity. If you're moving by some other random amount, you would need to use, say, the difference between where the particle was and where it's moving to, which of course if you subtract both of those is the direction, if you can calculate those. And that's not always straightforward, which I also found. And I'm not covering that now, but if you can figure out what that direction is, you can pass that in by inheriting the direction and then rotating your particle strip. So then you always get the particle strip width to show up. So it's a very useful little piece of knowledge to know, and I wanted to share that with everybody. If you're using these particle strips, it's something you have to keep in mind and figure out. So that's pretty much it. Next, I'm going to be working on some effects that use more kind of smoke effects and versus, bright effects. But in order to do that, you need to be able to draw some good images for your particles. And so I don't use GIMP a lot. I know on some videos I watch, they use Photoshop. Photoshop is a big package. It's expensive. Unless you do a lot of artwork, you're not going to want to pay for Photoshop. But GIMP is open source and it's free, but it does take a bit getting used to and figuring out. And so I'm going to be digging into that. So kind of what my next videos will cover is maybe some effects that use more smoke effects and things that utilize some of those better PNG images and manipulation of images versus manipulating the position and direction of our particles. So stay tuned for those, and I hope this helps kind of figure out how to use particle strips and that uniform circle. So one addendum here at the end, as I was looking at and putting together the video and watching it, as I was editing, I realized that it may be confusing that formula for the angle between the two vectors took the dot product and then divided by the length. And if you were watching this, you'll notice that this doesn't do anything with that length. And the reason is both of my vectors have a length of 1. It's one of the advantages of having a normalized vector. Remember, a normalized vector has a length of 1. So this direction is a length of 1, and then of course this vector, which we defined, is also a length of 1. So that's why we really don't need to divide by the lengths multiplied by each other, because of course 1 times 1 is 1, which is divided by 1 is just unnecessary. So just to clear up that confusion, So you can't be wondering about that.